So now I will explain you how to use this software, which is NanoScribe, and it is the software that you will use to transform your STL design into a format that NanoScribe can use to expose. So to open this software, we will double click into this icon and you will have your own license of NanoScribe for your computer. Okay, so NanoScribe will contact you and will send you the license to install into your computer. So this is the first interface that you see on NanoScribe, and to open a file we need to click on File, Open, and search inside of your computer to find your STL document. So I will choose this one and I will open. So in the moment that you open, you see a preview in this area, okay, of your structure. Using the mouse wheel, you can zoom in and out. If I press the mouse wheel, I can move around. Let me see if it works. Sorry, it's not the mouse wheel, it's the left click, okay? So you can move around your structure to see it in the different views or perspectives, okay? What we have, so this is the preview, and here we have some parameters that we need to adjust in several steps. So the first step is the model. The next step will appear next to the main one that we are seeing, and to go to it we just need to click. We can also go back, okay, if we need to modify something in the previous step. So let's explain the things that we will find in the first step of NanoScribe, which is the model. Here we have the input. The input is talking about the name of the structure that we have, and it's named cube 150. I name it like this because it is a cube of 150 microns, okay? So here, if we open this list, we have a different set of preloaded recipes. These preloaded recipes are giving you already some configuration for your or characteristics to your structure. If we select one of these, some of these parameters will be already uploaded. If not, if we leave it like this, we can select all of them. If you select one of them, we can also modify. In fact, for example, for this one, let's say that I want to print with the IPS photoresist 25 objective, and I'm going to expose into an ATO coated substrate, okay? So I click in this one, and it's a 3D medium feature size, okay? So some of the parameters will be already preloaded, but we can change. Next thing that we see, next frame, is transformation, okay? Here we have undo, redo, or reset. Because if we do any modification and we regret, we can always go back. And if we want to go forward, we can also do. And if we want to reset the previous one, the original one, because we did many transformations and we decide, no, I want to go back to the original structure, we can press reset. Also, we have here some kind of, okay, here you don't feel it because it's 150 by 150 by 150, so you don't see, but we can rotate in X, Y, and Z. Okay, we can move also the origin from the center to one corner. NanoScribe recommends to use this one. So when you upload your structure, click on here and you will see how the 00 becomes in the middle of the structure base, okay? So next thing is to do the scaling. This scaling can be locking the aspect ratio in a way that if I modify one of these values, all of them will be modified in the same, proportionally. Or if I remove this, I can just type here whichever dimension I want to give it to any of it, and the rest will remain the same, for example, like this, okay? So if I want my design to be like this instead of the other one, I can leave it like this. And now I will show you, because now you can see how this is rotating the structure, okay? Before you didn't see it. So if I now log the aspect ratio and I modify this to double, it will be modified, all of them, okay? Let's say I regret and I want just to reset to the original one. So I just click reset, and voila, we have again this as it was in the beginning. I put again, this is in the center, and you have here important dimensions, okay, because the volume, okay, is one detail that you will know, that you will need if you are using the printing selector from the NanoGuide web page, okay? So this is the volume of your structure, and this is one of the dimensions that is asking in the printing selector that I mentioned in the first training part. What else? We have the display options always, okay? Because we can disable this preview. Why we can use this? Because sometimes if your structure is super complicated, or maybe you have one array, it's consuming a lot of resources from your computer and it's getting blocked. If you disable this preview, you can continue doing modifications you don't see, but at least your computer won't get stuck, okay? So, because this structure is quite simple and I want you to see, I will enable, okay? And also you can disable the calculations, these calculations, but I don't want to because I want it to be quite visible. So, let's do the size that I wanted to do it, because this is not, this is very small and I want to do this bigger. So let's say I want to do a cube that is 300 by 300 by 300 microns. Okay? So we can move to the next step. Slice. So what is this? What this means? Do you remember in the first part of, or in the first video I was saying this is a layer by layer two-photon polymerization technology? So if I go closer to this structure, can you see the different layers? This is the way NanoScribe is printing. So it's printing by layers. What NanoScribe is doing is dividing or slicing your structure in layers, and it's printing one layer, then another layer, then another layer, and then another layer, okay? That's why this is, and this is with the right, okay? With the right you can move. With the left you can rotate. And with the mouse wheel you can zoom in and zoom out. So, as I was saying, slice by slice is printing. So we can define in this step how big the slice is going to be, okay? The bigger the slice, the rough it will become, or rougher it will become. The thinner the slice, the smoother it will be your the surface of your structure, okay? But you need to reach a balance, okay? Because also it's not that you will define the thinner that you can do, because if I modify, for example, this value, which is the slicing mode, slicing distance, and I put 0.3 microns, this maybe is going to take much more time, because I will come closer and you will see This is now 1 micron slice. If I apply this to the view, and to apply this I need to press a slice, now I have many more slices. So this means NanoScribe will take much more time to print. Okay? So if you don't need to go so fine, just leave it maybe like this, and you will get more faster printing. Okay? And remember, you need to press a slice to see here the change, to see in the viewer. Okay? Any modification that you do in here, you need to click a slice. And we have 2 different options, fixed and adaptive. For this structure, because it's so simple, a fixed one will work. When we need to use adaptive, when your structure has different shapes and rounded shapes, okay? When it's changing, the surface of your structure is completely different, and it has different steep. Maybe one side is super steep and the other one is straight. So maybe there you can consider using the adaptive slicing distance. And if you choose that one, you can put a maximum and a minimum. And the NanoScribe will be calculating by itself which one is the most convenient for the steep that finds in that point, okay? So it will be between these 2 values. But for us, this is so simple, so we leave it fixed, okay? We continue. Next step is fill, okay? What is this? This is the interior of the structure, okay? So to save time, if you have a structure that is super big, you can use the shell and the scaffold, and we will have here one more step, okay? Because this is the way we are going to expose the interior of our structure. If we choose solid, all the interior is going to be exposed. The whole volume will be polymerized, okay? And we have here, which is the hatching distance, contour count, and base slice count. What is each of these parameters? Hatching distance. Let's go to show you what is this. I will show you it's easier to see with one image. Hatching distance. Up. Okay. Not this one. Sorry. Let's go. Yeah. This one. Okay. You remember that the NanoScribe was printing with the voxel, and the voxel was elliptical, right? So this is the elliptic shape, right? So it will be printing lines that will have this shape, and it will be filling each of these slices with lines. So you will have one plane, and NanoScribe is going to be writing lines, and each line will have this shape, okay? So the distance between consecutive lines, this is the hatching distance, okay? So coming back to describe, this is the distance that you can define between the lines, okay? What is the contour count? So this is the number of contour for each slice. So each slice is defined by the contour and the interior. So how many times you want NanoScribe to define the contour with a line? This is this number, okay? What is the contour distance? This is the same than the hatching distance, but for the lines of the contour, okay? The base slice count. This is how many slices you want NanoScribe to add to your structure. NanoScribe by default is adding 2. Why? Because NanoScribe wants to make sure that your structure is going to be perfectly fixed on the substrate. And when I mean fixed, it's going to be attached. So instead of just writing your structure, it's making a first exposure of 2 slices, okay, that are not going to be part of your design. They will be additional, like a base for your structure to be completely attached to your substrate. So I will ask you not to go less than 2. If you want to increase, okay, but please don't leave it to 0, because if by any chance your structure is not well attached to your substrate when you develop, you will lose it, okay? So the same than before, than in the previous step, any modification that you do in these numbers, you need to click Generate Solid, okay? So it will be transferred into this image. If we want to do shell and scaffold, what this means? So this is to save time printing, because if we choose this option, NanoScribe, instead of printing the whole volume, okay, it's going to print a shell of the structure. So it's going just to print the exterior part of your structure and to leave the inside unpolymerized with a scaffold inside that you will see in the next step. Because when we click in shell and scaffold, one more step is in here. Okay, the same. You can choose also the different parameters for this shell, okay? You can choose again the hatching distance, the shell contour, the base slice count, okay? If you do any modifications on this, please click Generate Shell. Once you do the input of this shell contour, and the one that you need to pay attention is this one, because remember that you will have some unpolymerized photoresist inside of here. Unpolymerized means liquid, right? So if you don't give it enough thickness to these walls, and this will be defined for the number of these, maybe it will lose the shape. It cannot hold the unpolymerized resist that is inside, okay, without doing like pressure on the walls and modifying the shape. So you need to make sure that this wall is strong enough to keep the shape of this volume that is inside of unpolymerized photoresist. So let's go to the scaffold, to the interior. Is the scaffold completely unpolymerized? Well, you can choose. If you leave it hollow and you click Generate a Scaffold, you won't print anything inside and it will be completely liquid. But if you choose one of these 3 options, triangles, tetrahedron, and planes, you will create different shapes of scaffolds that will help to maintain the shape of your structure. And if we go closer, you see that the shape of this is triangles, okay? And here you see the lines that NanoScribe is printing. Sorry, I'm moving too much this. I will go close again. Okay, each of the lines that NanoScribe is printing, okay, for this scaffold. So, and again, you can choose the hatching distance among these different scaffold types, okay? The strongest one is triangles, but you can use also tetrahedron, and if I click Generate Scaffold, we have tetrahedron, and if you can choose either planes and generate a scaffold, so we will have planes, jet planes, okay? So you can generate this scaffold. Why is saving time? Because NanoScribe doesn't need to print the whole volume. So you will save a lot of time, but a lot. What we will do if we choose this type of structure is after processing our sample, so we will expose, we will develop, and after developing, we will do a float exposure under the UV light in a way that we polymerize the interior of your structure. But it's much faster than doing it with NanoScribe line by line, right? So the recommended one is triangles, okay, because it's the strongest one and it will help you to maintain the shape of your structure. And you can choose here the hatching distance. Please click generate a scaffold. If you open this, you will have much more characteristics that you can optimize for your scaffold, okay? So, but these ones are enough. So let's go to the final step, which is the output. And here, okay, you see different colors and it's a little bit weird to see this structure like this. What are these different colors? These are the blocks. Do you remember that I was saying the printing field in the first video, right? This is related to this because if you remember, I gave it dimension of, if I don't remember, but let's go to the first step. I put 300 by 300 by 300 and it should be like, oh sorry, output. Now we cannot see. It should be the size of one of the blocks because 300 is enough. So let's look into that, why is happening and why is dividing my structure in different blocks, because each block will cover the area of the printing field, okay? So first, also I want to show you this icon that you see here is telling you that there is a problem. The problem in this case is not important, is that I already have one file with this name. So it's telling me, Erika, this file already exists. Do you want to overwrite? And if I click here, I say yes. So I will overwrite. It's just telling me that there is a problem and I need to pay attention. Okay. So in the output, what we have? The first name, which is the name that we gave it to the file. And these files are going to be created by the scribe whenever we click save. Okay? And these files are completely necessary for the exposure. And my recommendation is that you create one folder for each structure, and inside of this folder, the scribe will create all these files. And you cannot change the name, because if you change the name and it's not coincident, NanoScribe cannot print. Okay? So that's why I say to the users, please just create one folder for each structure and keep there all the files that this scribe is creating. Okay? Because it's going to create these two and even more that we don't see in here. Okay, the scan mode and Z-axis, this you don't need to touch. Hatch lines, there is no need also to touch. Exposure, we say shell and scaffold. Configuration is deep in laser lithography. You don't need also to touch this because normally it comes just by default when you choose the recipe. Okay, and now I will, here is the one that I wanted to do. Splitting mode. Okay, I don't need to do a splitting mode. Why? Because my structure can fit inside a single block. Remember, my structure is 300 by 300 by 300, and I'm using the 25 objective. So the most restrictive one to define the printing field is the piezo. And the piezo has 300 by 300 by 300. This means I can print this structure in one single block. What can I do more? I can create one array. Okay? If I click here and I create one array, I can just tell NanoScribe, I want to print 3 by 3. And I see a spacing. Okay, I have here one alert. Why? We don't see separated units because this is too small. We need to give it more space between of them because the cubes are 300 by 300 and this distance is between the center of one structure to the center of the next one. Let's give it 500. In X and 500 Y. So now we see the array of structures. But listen, you can only use this array if your structure can be printed in one single block. If your structure cannot be printed in one single block, we need to use another tool that is inside of the scribe to do this array. And I will explain in another video. Okay? But if your structure is fitting it here, you can do the array. If your structure is bigger, and we are going to do it now, I want you to explain you how you can divide it in the different blocks. Okay, let's remove the array. We don't want one array. And let's go to the first step because we are going to make our structure much bigger. Okay, in a way that it doesn't fit in one single block. Let's do it 900 by 500 by 300, 350. Okay, so it's big in all of them, right? So then when we go through the steps, here we cannot use this because it's bigger than one single block. Remember, the single block is 300 by 300 by 300. So what we need to do is to split our structure in different blocks. How? We can choose in two ways, rectangular or hexagonal. This is up to you, okay? I will go for the rectangular, it's more clear. So now the scribe is dividing your structure in the different blocks, okay? To be able to print all the structure because the piezo can move in this area. But when it's finishing printing this, it will go to the next one and then to the next one till your whole structure is completely exposed. Okay? Now let's have a look in the block size. So we have here the block size and it says 285 by 285 by 200. Can you modify this size? Yes, but pay attention to this. Okay? The block width. Because the final width is higher than 300 microns. And this is telling you that I'm sorry, I cannot print this block with this size in a single go. And you will say, why, Erika? It's less than 300. Because if you pay attention, we have here like an angle, right? And this is defined by this, by the block shear angle is 15 degrees. And I'm going to explain you why we use this, going to the web page of NanoGuide. Can you see this image? These are tests that are done by NanoScribe. And if you don't use any angle when you divide your blocks, it's creating stitching problems. So the more the angle you give to your blocks, the better the stitching between blocks to avoid any separation. So the quality of the exposure of the final structure is much better. And the minimum shear angle that is recommended is 15 degrees. That's why when you go to describe, you find here 15 by default, because it's the minimum one that is recommended, okay? And because of this angle, you can see that the final size, because if we take the measurement from here till here, and we write a straight line, this final size is bigger than 300. Okay? So we need to reduce this size until even less, 245. Oh, too much. 245. A little bit. 240. Yes. 240. It's asking me for a little bit less because maybe it's too close to 300. 220. Now, yes. 220. You can also modify with these arrows, and go little by little to see which one works for you. 220. Okay, now we don't have any symbol for alert, right? So we have the block size, we have the block offset, and we overlap a little bit the blocks as well. Okay, and this overlap is in here. Why? Because we want to avoid the blocks to be separated, so we choose 2 microns to overlap, okay, between the blocks in this direction. And also we overlap the layers of blocks in this direction. Just by 1 micron, you can increase it also to 2 microns, okay? So we overlap a little bit, and we are making sure that these 2 layers of blocks are not going to be separated, okay? What else? So also we have the block order. This I don't recommend to change because any of them will be fine. But the one that you need to click for sure, and is already clicked by default, is avoid flying blocks. Because this structure is obvious, there is no block flying. But if you have one structure that has something hanging here, and the structure that is here is printed before the branch that makes it together, this other structure will be flying, and you will lose it inside of the photoresist, okay? So please make sure you click on this to prevent any error, okay? When we finish everything, so we can click save, and now we come back to the original page when we open Describe, and here this is the program that NanoScribe is going to use to expose your design, and it has all the parameters, okay? And I have to say that these parameters can be modified. So these numbers, the laser power and the scan speed, they need to be optimized. And I will show you how to optimize in another video, because this is, you will need to run a Swift parameter run to optimize these values for your structure, okay, to know which are the best parameters that you can use for each structure, okay? So we can do one more thing, which is a 3D preview. Whenever we have here one program, we can click 3D preview, generate, and we see here our structure. If we click in play, we can see how NanoScribe is printing in reality. This is super cool, okay? You see how it's printing in blocks? Now it's better to understand what each block means, right? And also, you can see in here an estimation of the time that it will take to expose. And once you have this is the file that you will load into NanoScribe whenever we go to the lab to do the exposure. So after we finish all the transformation, this scribe is going to create all of these files and folders. And listen, you should bring all of them into the tool to be able to expose. In reality, as I mentioned before, the file that we will load is the job, but the job will be calling the rest of the files for the exposure. So what I really recommend is, I'm going to close it now and show you that I have one single folder for the design. And this is what is recommended, like keep all the files in the same folder, and you should have one folder for each design, okay? So coming back to the scribe, there is one more thing that you need to learn how to use, which is how to use the Swift parameter tool to create an array of structures whenever your structure is bigger than the printing block. The same operation is the one that you have to use whenever you want to make an array of structures and modify the printing parameters for each one of the items, okay? So I'm going to do the array for the structure that we have just transformed in a way that I can expose this array on NanoScribe and later see which one of these structures is the best. And this is exactly what I mean. If you can see, this is what we are going to create with the Swift parameter tool. So we will create one array of features, and each of these features is going to be exposed with different parameters. After the exposure and development, we will be able to inspect under the SEM microscope, and because you can see here that NanoScribe is writing which are the parameters for this structure, you will be able to choose the one that is the best. And then you will grab these parameters and then you will do the input of these values in the program that I showed you before. So let's start to do this. We are coming back to NanoScribe, which is already open. And to access this Swift parameter, we have to go to File, Advanced STL Processing. I'm going to remove all the things that I did previously to show you from scratch. Okay, so first thing to choose, and here we have batch processing and parameter sweep. The one that we are going to look into it is the parameter sweep. Okay, so in the source file, we will need to look for the file that we want to use. In this case, is the file that we were using, the STL file, open, okay? And we see here we have the dimensions that we input, okay? In this case, we can choose also a default recipe, even though we are going to modify this recipe for each of these features or for each item in the array. So we will continue with the same standard recipe. And now we will choose in here, in the parameter sweep, how many instances we want to write. Okay, in this case, for example, let's do 6 by 6, for example. So we will have 36 cubes exposed with different conditions. And to choose different conditions, we will be modifying in the x-axis one of the parameters, in the y-axis another parameter. The parameters that I recommend to start playing with to adjust the exposure conditions are the laser power and the scan speed. Okay? So in the x-axis, let's say we want to modify along the x-axis the laser power. So we need to select the category, and this is inside of exposure. And inside of exposure, we select the parameter that we want to modify along the x-axis. In this case, we will choose the shell laser power. And also we will add one more parameter because this is for the shell, but we also we will look into the core laser power, okay? So we go again to exposure and then core laser power. And then we will need to click into these arrows to expand the options for each of these parameters. Now we see 6 values. In this case, they are constant. And this is useful if we want to expose, because we already know the conditions for our structure, so we just need to do one array. Remember that you cannot do an array with the other option if your structure is bigger than a single block printing. And this is the way you will do the array in this case. Whenever your structure is bigger than a single printing block, you need to use this parameter sweep to create the array, and then you will put a constant value for the exposure conditions that will be the best conditions for your structure, okay? So, but now we are doing the parameter sweep as a test run to find the best conditions. So we are not going to leave the same value. What we are going to do is to modify. To modify these values, we have 1, 2, 3 options because constant is just constant value. If we click in manual, we can type in here any value that we like, and they will be different values, okay? If we type extrapolate, and this is the one that I use normally, we will write, for example, the first value, then the second, and then the describe is going to calculate, to extrapolate this step, and it will apply to all the values. Or we can interpolate and then establish the first and the last, let's say, for example, 100, and then it will interpolate the values that are in between these two maximum and minimum, okay? The same thing we are going to do with the core laser power. Let's say, let's use the same values. And now we see the label. The label is something that we also can modify, and this label is what we have seen in this picture. You see this? Exactly this name, okay? So it's kind of the name of the parameter, okay? So when you read it, when you check the exposure, you read this label here. So you can change the name, or you can leave the same label that Describe is giving you by default, okay? So let's say in the x-axis we have finished, and then we will move into the y-axis. Then in this y-axis we will modify the other parameter that I mentioned. One is the laser power, and the next one is the scan speed, that is also inside of the category of exposure. So we will choose also the shell scan speed, and we will add as well the the core scan speed, okay? Because this is the speed in which the NanoScribe is moving, okay? So the slower it goes, the more energy you will put into each point, okay, or each pixel. So let's modify this value. Again, we extend these frames to see all the options, and we choose the one that we want. For example, let's say also interpolate, and we start choosing 75,000, and then we interpolate 75,000, and then we interpolate into this value and into this value. And again, the label, shell scan speed, core scan speed, you can leave it like this, or you can modify. So the output of this will be another file, and this file name this time will have the surname of sweep job, and this is the job that we will need to load into the system again. So once I click run, this program appears here, and if we generate the 3D preview like before, we will see here the array that we have created. So we can zoom in to see that we are exposing what we are exposing, and we can see here the label for each structure. So it's easy to recognize what are the parameters that we have used to each of these structures, and to choose the one that is the best, or the one that is giving us the best results. So this is the way you will be adjusting your processes whenever you use a new structure, or you change the photoresist, or you change maybe anything that is a change in your process. You should be doing this first run to adjust the conditions, okay? And now, once you get the conditions, imagine that the conditions are, I don't know, 85 laser power and 90,000 scan speed. We go to the previous job, and here we just type in the laser power that is good for us. Sorry, did I say 85? Oh, okay, let's say it's 85 and 90,000 and 90,000 the scan speed. So from here we just need to save, and all the data will be saved. So we will have the parameters that we want, and then we will be able to expose with the best conditions. So thank you for your attention, and I hope you enjoy using NanoScribe.